Okay, there we go. Another uh, discussion with jungle jargon and maybe somebody else if they happen to notice. But I've had some good, encouraging feedback on my, you know, explanation, my astrophysics explanations and stuff. And I get feedback in my other stuff too, but it's just significantly better or more, at least I noticed, on my analysis of the space time and everything like that. So hello Doki, how you doing? God bless you. Hope everything's good. I invited Lionfarm because maybe I think he wanted to have a discussion with me, but I told him maybe this weekend, so I'll see if he shows up. But in the meantime, I'm gonna just review my space and astrophysics discussions, which seems to have been working out pretty good. Let me try to do a share screen here. Okay, share screen, testing, share, and try this here, and try that here. Okay, so now I need a little file. I need a file here, so I can do my SpaceX. Okay. Now, I guess I'll go ahead and go with this picture here. Oh, wait a minute. I have to do share screen first. Hide this thing. Go back to share screen. And why is this on this one? Anyway. Uh, Anyways, I guess it's not. This might be the wrong screen here, but at any rate, hopefully this thing is sharing okay. Yeah, it's sharing okay, I guess. So now this is a phenomena here where they had a galaxy, basically a galaxy, shoot out this plasma light beam. This light beam plasma is basically plasma. Plasma is not even supposed to go as fast as the speed of light, but they measured this thing, and initially their initial estimates were that it was 5 times the speed of light. So 5 times the speed of light, you have a problem. But what they tried to say was that, well, because it was pointed in our direction, somewhat in our direction, maybe halfway or a third in our direction, whatever, quarter in our direction. They said, well, you have to combine the speed of light plus the rate it was shooting out, which accounts for the 5 times the speed of light, which is total nonsense. Because how can you're not even going to get double the speed of light, much less 5 times the speed of light. So they have a serious problem here because their observation is that they're assuming that this distance here is the same as this distance here, which is the same as this distance here. But the problem is that once you get away from the center of this galaxy, you have an expanded measure of distance. So let's say, for example, from here to here is 1 light year. I don't know if that's accurate, but let's say from here to here is 1 light year. And let's say from here to here is 1 light year. That's the expansion of distance right there. Not only is it an expansion of distance, once you get away from the center of this gravity well right here, you're going to have a faster rate of time. So not only does the distance expand, but the rate of time goes by faster. So here we got 1,001 second long. A second, that's 1,001. So it's 186,000 miles a second. Okay, let's say, I'm interchanging examples here, but let's just say for the sake of discussion, this is the time it takes for this light to travel from here to here. Let's just say it's 1 light second. 1,001. That's because the second goes by slower. Here, let's say it's just normal. Just say it's 1,001. That's a normal speed, let's say, just for reference or just for an example. But then from here to here, the expansion is such that, just for, by way of an example of the expansion of distance, to say 1,001. In other words, the second goes by a lot faster out here than it does here or here, because the rate of time is, so events happen a lot faster. Not only is the distance expanded, greatly expanded, but the events occur at a faster rate. So that's more time here. It's more time here going by. In fact, it's going by faster. Time is going by faster out here than it is here or here. So they're not even taking any of this into account, and they're measuring, from here to here is such and such a distance, and they said, the plasma beam shot out, because it was an observed event. It was an event they saw occur. They're saying, this plasma shot out 5 times faster than the speed of light, according to their calculations of distance. Of course, that's absurd. It's totally absurd. Anyway, so yeah, hopefully Lionfarm, he wanted to have a discussion, and I just wanted to introduce him to my newfound ideas on the genome, the Y chromosome haplogroups. So if he shows up, that would be interesting. So yeah, so that's basically what it is. Of course, I've shown these other things here. I wanted to get into James Webb a little bit, talk about James Webb, discoveries. Okay, this is an interesting thing. Is what it seems to be is that this is like what do you call it? More than one star, a binary star system. So how do we know this is James Webb? Well, because of the 6 stars. 1, 2, 3. The 6-pointed star, which is basically 1, 2, and 3. It's a 6-pointed star, basically, with the exception of this. But it's basically 6-pointed. So that's the James Webb observation here, because it's a 6-pointed star. That's 1, 2, 3, 4, 5, 6. But anyways, this binary star system it's an interesting observation. First time they ever observed one like this, or I guess this clear or something this far away. I don't know. But as this binary star system is orbiting each other, they're putting out clouds of dust or something, I guess. It's just an interesting observation. And Every time it goes around, it puts out another layer of dust. So something is shooting out a dust layer as it's orbiting, and it makes this interesting pattern here. So that's just an interesting picture. That's all that is. Okay, so, but as far as the James Webb is pretty interesting because let me see if I can pick this up here with the slideshow. This works. Okay, I got the slideshow now. Okay, so this is just an example here of a gravitational microlensing from a black hole. So what happens is you have a star behind on the other side of a black hole. This gravitational well right here causes the light to bend so that you will see, so you end up seeing a star, and if it's the right distance, it'll be the fully formed star, but it'll be much closer than it actually is because it's actually twice as far away. That's if it's the correct distance away so that everything lines back up again. They don't always line back up correctly or perfectly, but that's just to give you an idea of what the James Webb is able. Well, this is talking about the Hubble. This is the Hubble right here, but it's just an explanation of what gravitational lensing is from a black hole. You have two microlensed images appear as a single brightened star, which is probably not all that common, but that's just to give you an idea of what gravitational lensing is. So here's another example. Let me see. You got a cluster lens locate most distant sources. In other words, you have two telescopes in one. What it effectively does is has two telescopes in one. You have this telescope here, but then you also have the gravitational lensing effect, which magnifies even deeper into the field, a deeper field. Okay, so this is according to their this is the supposed age of the universe. But remember that with no matter in between us and the object we're viewing, the faster time goes by and the greater distance is expanded. So it's actually not as far as what it appears to be because of the expansion of distance, plus the time goes by faster, so the events happen a lot faster, so that we can actually see billions of years go by while only thousands of years are going by where we're at. It's really very simple. But anyways, this is another example of the lensing effects. You'll see sometimes 1, 2, sometimes 3 and 4, which is called the Einstein cross, images of the same event. So if you have an astronomical event here, it'll show up here or here, then it'll show up here and here and here. And sometimes years apart from each other, which shows you that, the speed of light can be varied, or it is varied, depending on how much gravitational lensing is, which, for all intents and purposes, is traveling a greater distance sometimes because of the contraction of space. Since, in other words, the distance from here to here is one distance, but once you get to the gravitational lensing effect, then you're going to have the same distance in small amounts because of the gravity well. So you have space contracted so that it takes longer for the light to pass through the quote-unquote lens, which is exactly what a glass lens does. It slows down the light more here than it does out here, which causes the lens effect. The exact same thing exact same principle. So it actually slows down the light more here than it does here. So actually this would appear first and then this would appear because the gravitation of, if the gravitational lensing is stronger here than it is out here. But it's basically the same thing as a glass lens. So we aren't exactly seeing what is actually occurring. This is interesting because it's the Hubble optical. This is the Hubble optical. This is the Webb infrared. And then they just combine the two pictures. But what's interesting is here with a Hubble, all you see is clouds basically. Once you go to the infrared, you're looking through the clouds, so you see all these voids in here, and you see the actual star formations, the actual spiral arms. So you can see actual spiral arms here without the clouds. Whereas here, you see a lot of clouds, and here's both clouds and star formation. I don't know why they combined it, but that's just, I guess, to make it look interesting or something. But so this infrared can actually see through and penetrate a lot of dust because of the wavelength that it's using. Okay, again here, distance galaxies. Actually, this is with the Hubble. How can you know? Because it's four. It's a four-pointed star, and or eight, but it's not a six-pointed star. Your six-pointed star would be 1, 2, 3, like that. But this is just a four-pointed star, so this is a Hubble image, but it's showing you a distant galaxy. Now it comes up as a blob here, but it is a fully formed galaxy. You can tell it's fully formed, but it's in the infrared wavelength where it's deeply red shifted. So that's why they need the James Webb so they can see better here. Here's an example of an Einstein cross. You have to kind of like look here is 1, 2, 3, 4. Here. What it is the same image. You're looking at the same image four times. You're seeing the same image four times. Or if it's event, you'll see the event happen in four different places at four different times, sometimes years apart from each other. And sometimes they can calculate the difference. But this is still a Hubble image. Okay, this is an Einstein ring, which is basically what the first example was showing about the gravitational lensing. The image is a split, and then it's brought back together, and that's what you're seeing right here. Here is like a galaxy or something. This is like an image of what's on the back side of it. It's called an Einstein ring. Now this is a James Webb image. This is what was so shocking to all the scientists. Of course, each one of these stars are individual stars. Each one of these six-pointed stars, now we have 6 points, right? 1, 2, 3, 6-pointed stars now. So this is a James Webb image. And we can see what caught my eye the first time was this extreme gravitational lensing here effect, where you're seeing galaxies way back on the backside of this gravitational well right here, which is probably right here, the bigger mass, because that's where it seems to be circling around. And what you're seeing is galaxies way, way off in the distance, extreme gravitational lensings, and many times stretching the galaxies out. But the shock is that these are really fully formed galaxies. And oftentimes you can see they're spiral galaxies, but they're fully formed galaxies way, way off in the background, way, way off in the distance. And you can see and you can tell how far they are because they're redshifted in an infrared spectrum, infrared wavelength. They're still redshifted. They're still so this means that they're way, way going way back into the far distance, and it's a fully formed, many times spiral galaxies, which I hope to be able to show as well. I don't know if this image shows it, but some of them are showing fully formed galaxies. And of course, the more red it is, that's essentially the farther away it is. In the and this, of course, this would be a huge galaxy here if it wasn't gravitationally lensed. Brings it up closer so we can see it, but it's actually twice as far away. But we can see great detail of this galaxy, fully formed galaxy, because it's not a star, right? It's not six-pointed star. It's just uh, pixels of a galaxy, fully formed galaxy, but it's very, very huge. If this was the actual size, it would be a huge galaxy, just like some of these are here. But this is very, very far away. And I don't see too many distant galaxies that are spiral. Maybe a couple of these are. Like some of these might be. I mean, they're all spiral. They're just you know at an angle or they're stretched. Now this is interesting here. They're all excited about exoplanets. That means planets from other stars. So this is an individual star. First exoplanet image. So this is the first actual image of an exoplanet. Okay. Which is interesting, but because they weren't able to see an actual planet orbiting a star, they would look at how the star was dimmed as the planet passed by in front of it. It would dim the starlight, and that's how they knew there was a planet in going around the star. But with this James Webb image, with all these different filters and everything, you can actually see the planet. Okay, so the star is here, the planet is here, star here, planet here, star here, planet here. And with all these filters, star here, planet here, star here, planet here, you can actually see the planet. So they're all excited about this, You can actually see the planet. Of course, this is like filtered, so it's magnifying the filtered light. Star is here, of course. This is where the star is, which with the regular without the filter, it would look like this. You wouldn't even be able to see the planet. Or like this, you can barely see the planet or barely see the star. But with the filters, you can actually see the planet or light from the planet using special filters, of course. Because otherwise, but that's the first time. That's why they're all excited that they were able to see an exoplanet. Now this one is interesting. We have to double check, make sure this is James Webb. Yeah, this is a James Webb image. It's got 6 pointed stars in it. And the interesting things We'll just go ahead with what they're illustrating here. This 7A, 7B, and 7C. So 7A, of course, they have a whole bunch of them. But this is 7A right here. This is 7A. And they have it magnified as this right here. So these are basically two galaxies together, slightly warped, because of the gravitational lensing, they're warped. Now, when you go up here, it's the same two galaxies, 7B. See the two arrows? Two arrows here. So 7B. These are two galaxies here. Of course, these are going way, way back in the background, back in the distance, very far away. Of course, expanded distance and an increased rate of time. The light we're receiving is increased rate of time, but because of the expanded distance is the reason for the redshift, extreme redshift, where they have to use the infrared James Webb telescope to be able even to see it, because otherwise they couldn't even see it. So, but the reason for the redshift, the reason for the extreme redshift is because of the extreme expansion of distance between here and there, where there's no matter in between. Because the photons that are reaching our eyes here are passing through space that has no matter, with the exception of the gravitational lensing right here, which helps to magnify it. And then you have the 7C, and you have the same two galaxies right here close together. Of course, they're fully formed galaxies. You can actually, I don't know if you can see it, but you can actually see spiral arms here. You can actually see a spiral arm there. And of course, this is what shocked the scientists, is that with these galaxies are going way back into this, the supposed beginning of the formation of the universe, which at that time they don't believe, because they think they're looking way back in time, which they're only looking back 6,000 years. But as far as they're concerned, they're looking so far back in time that these galaxies didn't have enough time even to form, even to coalesce into a galaxy. And yet we're seeing spiral arms here of the galaxy. And so that was the shocker of the scientists. Now they're going to backtrack and say, "Oh well, it can be explained." They're going to try to explain it some other way. But of course, it was our prediction. We said these galaxies are going to be fully formed. I said that myself. I might have been talking to myself, but I said, I'm almost positive that these galaxies are going to be fully formed. And sure enough, it was. And that's what the shocker was. Okay, so let's just give you an idea of this extreme gravitational lensing effect. Not only that, but that these galaxies here are fully formed. They're actually fully formed galaxies here. 7-1, 7, and then they have a whole bunch of other examples. But these here are so far redshifted that they're like going back, basically, I don't know, back to the supposed formation of the universe, or near the formation of the universe. Anyway, and again, basically the same thing. Mirrored star clusters. Okay, I don't know if this is a mirror of the same star here or what. It's hard to say. But anyways, this is obviously a gravitational lens effect right here. Uh, Again, what is this? Oh, this is just a regular ring galaxy. It's probably Hubble, anyways. This is the smiley face ring galaxy, Einstein ring, but this is a Hubble picture. But this is the famous smiley face. And this is the fully formed, well, fully formed, yeah, but this is still a Hubble image, though. It's still a Hubble image. And even then, even way back then, they're talking about fully formed galaxies over here. Or or they're saying this blob here with a Hubble is this galaxy here with a James Webb. So the James Webb is able to see what the Hubble can't see. If that's the case. Because this is a Hubble image here, and this might be a James Webb image there, just to show the contrast of the fully formed galaxies. Now this is redshifted here. This one here, oops. This one here is extremely redshifted. Oh, come on. Oh, I can't get it. But anyways, this one here. This one here, extreme redshifted, but this is even more, where you can hardly even see. You can hardly even see a blob. You probably can't even see the blob, anyways. So much for that. But with the James Webb, you can see it. Basically, the same thing. The light's normal path would be like this and like this. You'd be able to see it. If we were out here, we'd be able to see it. But of course, it would be too far away to see. And the James Webb is able to see it because it's infrared light that it's looking at, because it's extremely red shifted. So it's able to see a gravitationally lensed galaxy way back here in all these different places because of the fact that it's looking through infrared. Because if it was a Hubble telescope, it wouldn't even be able to see it. But since it's James Webb, it can see these gravitationally lensed galaxies that are supposedly way off in the beginning of the universe. But they're fully formed galaxies, spiral galaxies. They even have it represented here as a spiral galaxy here. Anyways, spiral lensing, okay. Basically showing a bunch of spiral galaxies, but not sure. Yeah, it's still Hubble. That's a Hubble image. This is James Webb. And of course you can see some of these are interesting. Of course, these are close up, but some of these way back here are extremely redshifted, which the James Webb can see, but they're fully formed spiral galaxies. These red ones, like this, a fully formed spiral galaxy, which is the real shocker to them because it's at the beginning of formation of the universe, according to the supposedly 13 billion years or 12 billion or 11 billion, whatever it is that they calculated, which is really only in our time it's 6,000 years. But if you're looking through space, you got expanded distance plus you got increased rate of time, so that's why it's 13 billion light years away, because the rate of time and the measure of distance isn't the same as our rate of time and our measure of distance. It's just that simple. Same thing here, just different galaxies. It's a Hubble. James Webb image with six pointed stars. So that's just basically another one. So this is what it is. Okay. Observable distant galaxy. Distant galaxy too faint to be detected. So this is what I was trying to explain. I don't know if it was able to be understood. These spots here were not detectable by the Hubble. These are observed distance, and of course they're extremely redshifted. But with the James Webb, along with the gravitational lensing, the James Webb is able to see this redshifted light that you wouldn't ordinarily be able to see. Okay, relatively nearby galaxy, gravitational lensing influenced foreground, observed by Webb. So it's observed by Webb, which means it's able to see light that the Hubble was not able to see because it's extremely redshift. Oh, this orange one. They got it as orange. I don't know why. I guess because it's magnified so much. I don't know. But usually this should be red, and these other ones should be orange. But this is light that James Webb could see that the Hubble could not see. In other words, the Hubble could see this. Remember, the Hubble could see these extremely red shifted. That's why they got it. Extremely red shifted by the Hubble. But these invisible galaxies here, the invisible galaxies, the James Webb is able to see the invisible galaxies because of the gravitational lensing. Plus it's not looking with visible light. It's looking with infrared light, so it sees the invisible galaxies redshifted in infrared light. If that's easy to be understood, I don't know. Now this is the interesting thing here. So this is the Chandra Deep Field. I guess that's the Hubble. It's the Chandra. Oh, the Hubble, HST, Chandra Deep Field. Yeah, this is when remember when they said they focused on a patch of space where there was nothing there, and they said, "What are you wasting your time for? You're not going to see anything." And a whole bunch of galaxies appeared, staring at it a long time. The James Webb can see farther back in time, but of course, span of time. But this is the interesting thing. This is supposed to be the first galaxies. This is supposed to be the first stars. This is supposed to be the first galaxies. But notice where it has it taken. The James Webb can see way back to the first galaxies. The first galaxies it can see, the first stars it can't see. In other words, it goes right back to the first galaxies, but not to the first galaxies. I mean, not to the first stars. In other words, it's trying to say that the formation, because this is supposed to be the dark age when there were no galaxies, and then all of a sudden galaxies form. All of a sudden you have fully formed galaxies here. These are all fully formed galaxies, which was, according to their Big Bang model, you have this extreme heat, this expansion, which is another thing. How can you have temperatures so hot that when it expands so much, it's obviously cools down, but to me it would seem like it would cool down too much with all the expansion, because when you expand stuff, it cools down. Anyways, you have the extreme heat here, plasma, and this is supposed to be the cosmic microwave background, which I question anyways. It could be, to me, it's just microwaves coming from ordinary galaxies. But they may have an argument against that. I'm not sure, but this temperature here is supposed to be the cosmic microwave background, which is like 4 degrees something or other. And but it's but it's the same everywhere you look in space. The temperature is the same everywhere you look in space. 4 degrees something, whatever measurement they're using. But then that's that's just microwave from supposedly the Big Bang. Now you have dark ages where you have all this matter didn't coalesce yet and didn't light up yet. And then here is where all this dark whatever, ions or whatever it was, they coalesce, they cool down enough to form stars. So you have the first stars, then you have the first galaxies. And they're just surprised that the first galaxies are so close to the first stars. Because according to the Big Bang model, they didn't have enough time to coalesce into galaxies from the first stars to the first galaxies. So that's what that's about. But that's the big surprise for them. And age of the universe, billions of years. Okay. This is how old it was. It's 0.3, 1 billion years. Anyway. Anyways, and then of course here, the modern universe is 13.7 billion years. But we still have spiral galaxies. If it's 13.7 billion years, why are you have the same spiral galaxies as what you have way back over here that the James Webb detected. The James Webb has seen fully formed spiral galaxies, supposedly, depending on your measure of time, but 1 billion years old. And you got the same spiral galaxies here as you got out here, fully formed and huge. Not only fully formed, but very, very large, considering the distance away that they are. Okay, this is a James Webb Saturn picture, which is very interesting. Of course, we got spiral galaxies. James Webb, spiral galaxies, and a couple of things. A lot of these are redshifted, but they admit that these are all fully formed galaxies and that they're spiral galaxies. You can actually see they're spiral galaxies. Fully formed and spiral galaxies. Many of them. But the interesting thing to me that they're not all the same redshift. Some of them are like less redshifted. You got the blue, you got the yellow light, or green, whatever it is. But they're not all the same redshift. Depending on which direction they're traveling or whatever, or how close they actually are. A whole bunch of things, but that's interesting to me that they're not all the same redshift, which needs to be explained as well as them being spiral, because they admit they're spiral galaxies. Fully formed spiral galaxies. Of course, these are extremely redshifted. You wouldn't even be able to see this with the Hubble telescope. And they're huge galaxies, fully formed. Okay, there's a difference between X-ray and radio waves. That's just what the James Webb is able to do, I guess. We're having some trouble with the James web satellite, but they're just in certain filters they're not able to use right now because it's too much friction or something. Something got jammed or something somewhere. Anyways, I guess maybe maybe Lionfarm hasn't seen this yet, or I didn't. He said he wanted to have a discussion. I said maybe on the weekend. So the other time I had a discussion with Lionfarm was like on a Sunday or something. So I'm just seeing if he'll stop in. So I'll just go ahead and reiterate some of my table of nations here. So let's see what we got here. What kind of pictures we got? So it's got the one where hard to say. It's got a lot of pictures. Let me see. I guess it's okay, but let's see. Let's see what this one's got. This might have it. Oh, here, this one here. This is it. Well, that's it, but it doesn't have my scribbles on it, but that's okay. So, of course, we know about the out of Africa. They're supposed to be A, B, C, D, E, and everybody else uh, supposedly evolved from the C, which would be Nimrod. I'm trying to say the rest of the world evolved from Nimrod or descended from Nimrod, because C is the only one. They had to connect it to C because C is the only one that's in Asia, except for D. D's in Asia too, but they're saying, well, the Eurasians didn't evolve, or the Semitic people. First, the Semitic people evolved, then the Eurasians evolved from the sea, which is the only one in Asia, so they had to tie it to the sea. But my theory is my projection, my what do you call it? My projection, my claim, my is that CT is actually the oldest son of Cush, the oldest son, and Cush is the oldest son of Ham. But this CT actually does connect Africans to the Semitic population, and everybody else, because CT is C all the way through everybody else, with the exception of the D and E. The D and E don't have this marker, which is something you have to consider. So maybe Nimrod acquired this identifier. I mean, Nimrod's father Cush acquired this identifier, gave it to Cush. Gave it to Nimrod. Cush gave it to Nimrod. Then Cush lost it, and these never had it. Or, whatever. Could have been any number of scenarios, but we know it can't be. We know the root can't be here. Y chromosome atom cannot be with the A. The reason why we know is because the A is Hamitic, the A, B, C, D, and E is Hamitic, and Ham is the younger son. Ham being the younger son can't have identifiers passed down to everybody else. What it is, Japheth is the oldest son, The identifiers in common that he has with the rest of the world are passed down by way of Japheth, by way of Shem, by way of Ham to Cush to Nimrod, but then these are the odd ones out. They're the odd ones out because down here you have SNPs, single nucleotide polymorphisms, which means each one has their own identifier. Each one of these has their own identifier. Whereas, in contrast, this identifier here, BT and CT, these are identifiers in common with the rest of the world. So that the odd ones out are the A and the D and the E when regarding the CT. So these are the odd ones out because it's not a single nucleotide polymorphism. It's probably because the more original genome, the more original Y chromosome would be from Japheth, Shem, and Ham, but the order has to be here. The root has to be here with Japheth, which means this identifier of the IJK is an identifier that is shared with Arpachshad, which is I and J, and K, which is Japheth. So that means that Japheth had this identifier, Shem had this identifier when Arpachshad was born, but then Shem lost the identifier and wasn't able to pass it on to H or G or F or C or none of these. These are the odd ones out that didn't have it. Of course, Shem can't pass an identifier on to Hamites anyway. But each one of these do connect. These do connect all these lineages. All these lineages are, in fact, connected with these identifiers. It's just that they're not these single nucleotide polymorphisms that identify a single lineage. It's not identifying a single lineage. Each one of these are a single lineage. But these identifiers are basically shared with everyone on up the line, not down the line, up the line, because the root has to be with Japheth. So it's instead of it being acquired as SNP nucleotide polymorphism, instead of being acquired, it was lost to these down here, and this is lost to these. So in other words, if you rooted the tree of Japheth, you would be able to make a tree going down the other way just as easily as you could going this way. Because, of course, the one that connects the Semitic population with the Eurasians is the oldest son of Shem. The one that connects the Hamitic populations with the Semitic population and the rest of the world is the oldest son of Cush, which is Nimrod. And Cush probably was the oldest son of Ham as well. But at any rate, these are the all odd ones out. These are the ones that don't have it. The rest of the world does have it. So it was in my prediction that these are the ones that lost the identifiers going all the way down instead of all the way up the way I have it here. This way is actually going up. This way is going down. Anyway, so I wanted to see if I could share that with Lionfarm, see what he has to say, because he pretty much has an idea of what's going on with these identifiers, because these identifiers they're not a joke. These are actual things, I call them identified markers. They call them markers sometimes that connect each of these lineages. So these lineages are connected by these markers. It's not a joke. It's not made up. That's the reason what concerned me so much was that these are actual genetic markers. You got an A, B, D, E, and then C, because the C over here is what connects the Hamitic population with the rest of the world here. But that's my prediction, is that if you rooted a tree with Japheth, which would be the Eurasians, would be K, L, M, N, O, P, Q, R, S, and T, which is not all included here, but if you did that, then there would be a clear descent or connection going the other way instead of this way. Because of Arpachshad, the IJ being the oldest son of Shem. It used to be thought that the oldest son, it used to be thought that Shem was the oldest son and not Arpachshad, but it turns out Arpachshad is the older than Shem because of a translation issue. Or Japheth, I'm mixing up names here. If I do that, it's hard to keep all the names straight. But Japheth was born first when Noah was 500 years old. Shem was born second when Noah was 503 years old, according to the math. And we know Ham is the youngest son because it says he was the youngest son. So that's the way it has to be rooted. That's why it's backwards. That's why the out of Africa is, debunked. And that's why it's no longer a mystery, to me anyway, as to how these markers got into place the way they are. Of course, they're looking for specific markers to connect Ham with Shem and Shem with Japheth. And they found it in Nimrod here, because he's the oldest son, and they found a connection between Japheth and Shem with the IJ, because Arpachshad is the oldest son of Shem. And then the odd ones out are the rest that no longer have the identifier. But if you rooted the tree with Japheth, you could find identifiers going with stair step the other way. That's my prediction. So it's no longer a big, huge mystery anymore. But anyways, I guess that's it for right now. If nobody else, if Lionfarm doesn't show up, then maybe I'll just run through this controversial, which should be controversial, this controversial breakup of the continents, because of course, in the days of Peleg, the earth was divided. And of course, the first thing that everybody says, well, it doesn't mean the earth, it means the people were divided. Yeah, the people were divided because the earth was divided. It was a traumatic event. Everybody got scared, ran home to their mothers and fathers and brothers and sisters. They all ran together, isolated in family groups, and began speaking their own languages. So that's what happened there, probably, in all probability. But anyways, so the word divided in Hebrew later came to mean as the waters flow, or where the waters flow between the continents. Of course, India, I believe, was already close, if not connected, to Asia anyway, and it just broke apart. So when they broke apart, North America was shoved up in the Arctic, and Asia or Siberia was shoved up into the Arctic, and that's the reason for the frozen mammoths and lions and tigers and whatever. Because in order to have glacial markings on top of the sediments deposited by the global flood, this ice age had to have occurred after the global flood, and the breakup of the continents had to have occurred after the global flood. Otherwise, you're not going to get the glacial striations, glacial markings. Oh, this one doesn't have it. Anyway, you're not going to get the glacial striations or markings going from south to north in all these places. On top of the sediments deposited by the global flood, with the sediment layers underneath, and with the fossils that were buried by the global flood in the sediment layers that also line up between the continents. So not only do you have the glacial markings, you got the fossils, both animal and plant, in the sediment layers deposited by the global flood, all connecting together, all connecting all these together. But you also have living animals that were separated too. Because while they're building the Tower of Babel, the animals started to spread out. The people were too busy trying to build the Tower of Babel. So the animals had time to get where they were going. They reached Australia, they reached South America, they reached North America, they reached Africa. Animals had time to get where they're going. That's the reason in Africa you have the African badger. You have the African honey badger with his counterpart, the greater grison. It looks just like the honey badger. It's the exact same animal in South America. Same thing with the leopard in Africa. You have the exact same animal called the jaguar in South America because it had time to get where they're going. Crocodiles, too, had time to get where they're going. So you have the same animals in both continents, and they can't possibly swim from Africa to South America. So the breakup had to have happened after the dispersion of the animals. And the reason why the people didn't make it to South America from Africa because they were building the Tower of Babel until 100 years after the global flood, when the breakup occurred, which caused people to isolate into family groups, which caused them to speak their own languages. Then they started to spread out from Anatolia, from Asia or near Asia, whatever. And then they spread like spokes of a wheel. They spread to Africa, to Europe, to Asia, to Australia, like spokes of a wheel. All the different haplogroups spread out in different directions from where the ark, where basically Samaria, where everybody was. Okay. Here's the fossils lining up, the plants lining up, the sediments lining up, the mountain ranges lining up, the features lining up. Same fossils here as here in India. Glacial striations, because they were all located on the South Pole, on one side of the South Pole. So when the Earth was spinning, it was wobbling around, shaking like, all kind of crazy things, wobbling. And then the accumulation of ice and the thing became unstable, broke apart. America shot up north into the Arctic, and Europe and Siberia shot up north into the Arctic. and froze all the mammoths and quick froze them while they had tropical vegetation still in their mouth. So it's not that complicated, really. But the problem is when people doubt what the Bible says. That's what the problem is. That's why you got quick frozen animals, quick frozen lions, quick frozen mammoths, and who knows what? It looks like an elephant. I don't know if it's a mammoth or not, but you got mammoths too. You got wolves, quick frozen wolves. Of course, the original wolves. There's a mammoth. Clearly a mammoth. Quick frozen. You know. And here, what's this? Is this the honey badger? No, that's not a honey badger. It's called the greater grison, South America. The honey badger's in Africa. Wherever that is. That's the honey badger in Africa. Same animal. He's just separated when the continents broke apart. Poor guy. Same thing with a leopard, a jaguar. Jaguar got separated from the leopard. Look, same animal. Same animal. If you don't know the difference, you probably can't even tell the difference. This is a jaguar. This is a leopard. It's the same animal. Completely compatible. Or here's Peleg, Eber, Arpachshad, Shemson, Arpachshad, Noah, Shem, Arpachshad, Salah, Eber, Peleg, Ru, Terah, and Abraham. Abraham, Isaac, and Jacob. So the interesting thing here is, this graph you can't really see, except that you can see this. This is interesting. I like this because this shows. Remember, Isaac said, I'm only so 130 years old, but my ancestors lived a lot longer. Shem lived. What's the age? Didn't say what's the age. Anyways, Shem was living when in almost the whole lifetime of Abraham. Isaac was alive when Shem was alive. Isaac probably saw Shem, who was the son of Noah. Of course, Arpachshad, Selah, Eber, the father of the Hebrews. Isaac knew, or they were living at the time Isaac was alive. Isaac remembers these people. That's why he told the king of Egypt, he says, my ancestors live longer than me. But anyways, Shem and Abraham could have known each other. Even Isaac may have learned firsthand about the world which was lost in the great flood. So Abraham, I believe Abraham, when he ran away, when he ran from his father Terah and Nimrod, he got in trouble with his father Abraham and Nimrod. Abraham got in trouble with his father Terah and Nimrod. He ran to where Shem was in Jerusalem, in Salem, the city of peace. And I believe Abraham was raised by Shem in Salem. It's a possibility. It probably is true. And, Shem and Arpachshad, Selah, Eber, they were all there. All these people were living. But he had to run away. He had to be hidden because he had to run away from his father and Nimrod because Terah was an official of Nimrod, and he got in trouble with him, and he had to run away and hide. And Nimrod killed somebody else thinking it was Abraham. Then he found out, and it's extra biblical stories, but still could have easily occurred, easily happened. Of course, you have Jacob and Esau here. Jacob's brother Esau may have killed Nimrod, who was the firstborn son of Ham, who was the youngest son. In other words, Shem was born about 502, remember, or 503. Remember, uh, Japheth was born when Noah was 500, 502 after the flood. He lived 502 years after the flood. Anyway, something like that. Anyway, so the youngest son, the youngest brother of Shem and Japheth had a son named Cush. I mean, no, his name was Cush, but he had a son named Nimrod, which was the cousin of Arpachshad. But Nimrod, so Nimrod was the cousin of Arpachshad, but Nimrod was born after Arpachshad, and it's possibility that Jacob's brother Esau killed Nimrod, which is some accounts have him doing that. Anyway, another can of worms, or whatever. But this is the important thing here is you have people living almost 1,000 years. The global flood put a stop to that. Noah lived 950. But after Noah, they lived what? Less than 500 years. So their lifespan was cut in half from less than 1,000 years to less than 500 years. And then what happened? Oh, Peleg, yeah. The days of Peleg, the earth was divided. The lifespan was cut in half a second time from less than 500 years, they're living out here, to less than 300 years. Less than 300 years. In the days of Peleg, the earth was divided. It was like another catastrophic event happened, and it cut the lifespan in half a second time. So now you know the rest of the story. Because the word Peleg means divided in Hebrew. In Aramaic, it no longer meant divided. It meant as the waters flow in between the continents. Declining lifespans. Same thing. So you can see less than 500 years to less than 300 years right here. Cut in half twice. Except that it was 100 years after the global flood, in the days of Peleg, when the earth broke apart. It's a traumatic event. Everybody was isolated into their family groups. And the other one is the possums. The possums reached South America. The possums also reached Australia and Asia. And they're called, there's Novin. Jungle, during the separation of continents, do you think there were all living animals existed, or would that be before the flood of Noah? I believe that the separation was after the global flood, so that the animals were able to arrive in South America. The animals were able to arrive in Africa and Australia. But the people did not arrive in South America from Africa because they were in the land of Shinar building the Tower of Babel until the breakup of the continents happened. The breakup happened 100 years after the global flood while they're building the Tower of Babel, because God told them to spread out and they didn't. But then after the breakup of the continents, it was such a traumatic event that they isolated into family groups, began speaking their own languages. That's when they spread out, but it was too late for them to reach South America. They had to go all the way around the other way to reach South America. So it was the Eurasians that reached South America, along with some of the descendants of Nimrod as well. So you have the C and the Q reaching South America. You have the Hamitic populations, which is A, B, C, D, and E, except for the C. The C never went to Africa. The C is the descendants of Nimrod. They went into Europe. They went into Asia, but they never went into Africa, as far as we can tell. The descendants of Sinim, which is the descendants of Canaan, did reach Sinai, and Sinim, which is China, which I believe is a DY chromosome, which is more closely related to Mitzrayim, because it's Canaanites and Egyptians are more closely related than the Cushites, which is the C. Nimrod is the son of Cush, but the Sinites are more related to Mitzrayim. You have E1, E2, E3, which is Put, Mitzrayim, and Canaan. Sinim is a tribe of Canaan. They went to the Sinai. They also went up into here, Burma, according to the DY chromosome, Tibet, Burma. They went all the way east to the end of the earth, basically, all the way to Japan. You have the D, paternal Y haplogroup. Then the O's, the Magogs, came up and basically pushed them up northern Japan. The DY chromosomes, the Ainu Japanese are up in the north because they were pushed out of the south by the descendants of Magog that also permeated or invaded China, the whole land of Sinim. So that you only have Tibetan Burmas and some Paleo-Siberians up in this area here, and the Jomons that have the D haplogroups. So the area of the Denisovan Cave is actually an area where the descendants of Nimrod and the descendants of Sinim from the tribe of Canaan that lived. So that's the Denisovan Cave were highly Hamitic, but they're also descendants of Japheth, so that people in Papua New Guinea have more Denisovan DNA than anybody else in the world does. And the Neanderthals are only more closely related to the Eurasian Japhethites. So that's about it. It's about that. So, guess that's it. All right, Matt, hello. That's it. I was hoping to talk to Lionfarm, but he might be busy. I didn't arrange to talk with him. I just thought maybe he might be around to talk. He might see my live stream, but he could be busy doing something else. But he'll probably respond to the live stream anyways in a little bit. So I guess that's about it for right now. So thanks for everybody participation, and we'll get it all straightened out, I'm sure, because Lionfarm said D2 Japanese and DO Nigerians are the same. Yeah, because the DOs are from the tribe of Sinim. They're Canaanites from the tribe of Sinim. That's why the DOs and the D2s are related, because they're both descendants of Sinim from the tribe of Canaan. And the D2 the DO and the D2 are probably both from E2, It's either E2 or E1 because it's either Put and Canaan. E1 is probably Put. E2 could be Canaan. E3 is Mitzrayim, which is the Mitzrayim had the most descendants out of everybody. So most of the Africans that aren't Cushites are descended from Mitzrayim, but there are some descendants of E1 and E2, and I believe the D came from the E2 because it's on the same level. So that's, but he's right. Lionfarm is right about that. That the Japanese, the D2 and the DO Nigerians are the same from the same lineage because they're both descendants from the Sinite tribe of Canaan. So simple. everything fits perfectly as far as I can tell, and I expected it to. When I first saw the C haplogroup in Asia and the Mediterranean and Europe, I knew that could only be Nimrod. It can't be anybody else. Because Nimrod was the king of the world. He is the one that had the house of Nimrod, which is all his male descendants. Just like King David and King Solomon had the house of David, that's not just, father, mother, and 3 kids. You're talking hundreds, literally hundreds of male offspring of Nimrod. In fact, Nimrod had more male offspring than David and Solomon, or they were, through wars and stuff, were eliminated there somewhat or diminished somewhat. But Nimrod's offspring today is guessing is bigger than the J2, which would be the house of David, J2. It's actually the house of Judah, but a lot of the descendants of the house of Judah are actually from the house of David, which is the J2 M172. It's probably descendants of David and Solomon. But I think the descendants of Nimrod are more because they went all the way to America too, because they have all through Asia as well, or Mongolia. And into Europe. They went into Europe too, but they're basically died out in Europe, as far as I know. I'm not sure how many C1s there are in Europe, but if there's any C1s in Europe, they're descendants of Nimrod too. And that's the reason why they say that the Europeans were darker, the first Europeans were darker, is because of the influence of the descendants of Nimrod in Europe. So everything is explained. And it's the reason why the Olmec heads look Polynesians, because they have the same ancestor as the Polynesians, only it's a C3 lineage in America and it's a C2 lineage in Polynesia and the Pacific Ocean. But they have the same ancestor. So stands to reason that the Olmec statues look Polynesian. It makes sense. They look Polynesians, They don't exactly look African, but they do look Polynesian because they have the same ancestor. Anyways, so that's not too bad. I just wanted to, talk about the developments of the James Webb telescope, the infrared telescope, and their shock for them to see fully formed spiral galaxies all the way at the supposed formation of the universe, which is supposed to be a hot ball of gas. And all of a sudden you have fully formed galaxies, spiral galaxies, which are the same spiral galaxies that we see today near us, which makes no sense at all in the Big Bang idea. With billions of years passing by, makes no sense. Of course, time is going back slower in the galaxy than it is outside of the galaxy. It makes sense that the galaxy is far away. Time is going slower there too for them, but we can see the light because distances increase and time is sped up. That's why we can see the distant galaxy. That's why they're redshifted too, is because of the expansion of distance. The space between us and the galaxy is expanded, but not the space inside of the galaxy. Is not expanded nearly as much. So that's the reason why it's redshifted. The farther away you can see back in time because of the extreme expansion of distance causes the red shift. But they'll figure it out eventually. Okay, breaking it down, brother. Yeah, love it. Yeah, it's very interesting to me, and of course I've been thinking about this for decades. So I'm glad it's all fitting together very well. God designed it that way. God is so awesome. Absolutely. Yep. And we don't have to worry about the age of the universe because there's no single place in the universe that runs at the same rate of time. The age between us and the distant spiral galaxy is billions of years, but the age where we are is only thousands of years. And the age of that spiral galaxy, 13 billion light years away, it's only going through thousands of years too. 6,000 years too. So it's all explainable because the distance is expanded. The rate of time is running a lot faster, and that's why we see it. If there's no matter to slow down the rate of time goes by fast. Billions of years go by. Not to mention the collapse of the wave function, which is the whole nother can of worms. Anyway, that's about it. God bless everybody. Take care and stay close to God's word. It's His word that will convince us to do what's right, and He is able to keep us from falling. All we have to do is trust Him and believe Him and understand that He knows what's best for us in all situations. God bless. Take care.